Good morning to everyone, and welcome to one more 5G in America's webinar. This event aims to enrich the discussions about market perspectives of 5G and multi-access edge computing. Today, our guest speaker is Mr. Renato Pasquini, Vice President of Research at Frost Sullivan. Mr. Pasquini has been working in the ICT consultancy and research sector for 20 years and is currently Vice President of ICT Research at Frost Sullivan. Mr. Pasquini also works as an advisor to startups and associations in the ICT sector in Brazil. He has a bachelor's and a master's degrees in business administration from School of FGV, a postgraduate degree in economic law from GV Law, and in ICT business from UPC Spain. Our host today is Mr. José Otero, 5G in America's Vice President for Latin America and the Caribbean. Mr. Otero's work experience includes working on public policy issues for multilateral institutions and governments, such as the White House, the World Bank, and the Senate of the Republic of Mexico, and the Federal Communications Commission, among others. He is part of the advisory board of the Global Knowledge Index, published by the United Nations Development Project and the Mohammed bin Rashid Al Maktoum Knowledge Foundation. He has invited to participate at the International Telecommunications Union Expert Forum on Telecom ICT Indicators to help define how government entities can measure radio electric spectrum usage more efficiently. Mr. Otero publishes a weekly column in Mexico's newspaper, El Economista, and monthly columns for specialized media include Brazil's Canatech and Argentina's Telesemana. His academic background includes degrees from the University of Boston, the University of Edinburgh, Georgetown University, and the University of Cambridge. He also works as adjunct instructor at New York University, where he teaches courses of digital transformation and the impact of technology on business, public policy, and culture. So now let's hear a few words from Mr. José Otero.
Thank you, Ludmila, and thank you to all of you that woke up very early this morning to participate in this webinar. We have with us one of the main experts on Brazilian telecommunications and with vast experience all over the region, and know Renato for decades now. And he's going to be talking about a very important subject, which is 5G and how edge computer relates to 5G, because many of us always hear the mentioning of edge computer, the relevance of edge computer, but let's face it, not many of us have taken the time to actually read what it is and what it does and why it is relevant. I'm not going to take much of your time. I give the word to Renato.
Perfect. Thanks, José Otero, and thanks 5G Americas for organizing. I think it's a very important topic that we are covering today. Thanks everyone for joining as well. So we are going to present our insights about recent studies that we've conducted on 5G and edge computing. It's really an emerging topic. It's one of the key topics right now. I was in the Mobile World Congress this year, and all the telcos had use cases on private networks, edge computing, some of the key applications that can be developed. And they are placing a lot of bets and investing a lot in offerings, both to enterprises and also to consumers. And I'm going to present both our own forecasts and also some interesting end user insights that can enrich the discussion today. So this is the agenda. So first I'm going through an end user survey that we did. We do this annually, so we can compare the results year over year. And it's very interesting to see the adoption that it's coming from edge computing and also private networks. So I'm going to present some numbers on that. Then I'm going to talk about the market itself. So both some of the key trends, numbers for Latin America, and some forecasts, and the growth opportunities that we identified. So some of the key applications that 5G associated with edge computing can provide to different verticals. So what is edge computing, right? We define it more comprehensively. So can be IoT devices, branch locations, remote work environments, mobile devices, the vehicle itself. So the edge, let's say the data, the information can be processed everywhere. And there is a trend to process the information closer to the data, closer to the user. In mobile networks, usually all the data is transmitted to the core of the telecom network and then to a data center, like a centralized data center that can process everything and then return to the user. This resulted in, a high latency level, usually 100 milliseconds, for instance, for the applications. And this results in a bad user experience generally, especially for certain high-consuming applications like gaming, virtual reality, some applications that really require lower latency and are affected by the traditional way that the telecom networks were built. The key trend right now is basically to move the servers, the compute power and also storage to the telecom edge. So it can be a mobile network, for instance, either 4G or 5G, or even inside an enterprise facility, right? You can place the servers inside a factory, for instance, and then process all the information there. The cloud providers are extending their capabilities into the on-premise environment of enterprises. So the same equipment that you find in the AWS data center, for instance, it can be found right now in an enterprise running the same application services with the same tools and providing much lower latency. Based on our survey, 71% of businesses are using a hybrid and multi-cloud. This is up from 47% in 2021. So you can see really rapid adoption of this new environment using both private cloud, public cloud, and also edge deployments. And 54% of business have deployed apps at edge or branch locations as of the end of 2022. This is a very relevant number. The number is growing rapidly. We've seen a lot of developments from private networks in the past year. I'm going to talk about this later, but it's really a good moment to approach enterprises, even medium companies, and discuss the possibilities, right? What sorts of applications require to be run at the edge? What can be deployed? And then a roadmap of what can be deployed in the future as well. I think it's important to get together and analyze this. It's really a critical moment to be educating customers and also helping them on their challenges. This is basically the verticals, which ones are developing the applications at the edge. We can see a significant advancement in manufacturing, like from one year to the other, going from 36% to 59%, being the largest one right now. It's really a major achievement. It's the sector where we are seeing most advancement in terms of private networks with edge computing as well. So both in manufacturing, mining, oil and gas, all those manufacturing and natural resources sectors are quickly adopting private networks and edge computing for their applications. Has become a critical element and saves a lot of money as well. So in the past, you need to put fiber optics or cables throughout the entire facility or implement expensive radios. Now with 4G or even 5G, let's say you can cover a wide area or even indoor areas with really low latency, high throughput, and it can be deployed for mission critical applications. You can do network slicing, really guaranteeing the quality of how the application is run. So it's really, we've seen a lot of progress happening, especially in the manufacturing space. But you can see that in all verticals, the adoption has been, very significant, and customers starting to deploy proofs of concepts, trials, really understanding and learning how this can be implemented. And basically, when they are implementing applications in the edge, the key concern they have is around security. We've identified this challenge increasing year over year, so it has become really the top challenge right now, both for private networks, for IoT, for any sort of technology. With all the ransomware growing, the threats to business in terms of basically impacting the operation of companies and also damaging reputation. When it comes to, enterprise applications, mission critical applications, security, is even more crucial, as companies need to protect the operation, avoid interruptions, avoid a major disruption in production that could affect the revenue, the reputation of the company. So it's really an important element. Lack of staff to an effective deployment. So the enterprises are relying on system integrators, on telecom operators, cloud providers to be helping them achieve that. So when it comes to planning the implementation, doing it, sometimes even managed services, all the elements to keep the network running, and also be deploying the applications on the edge. So this is a critical element as well, and something that we observed many companies outsourcing this to a third party. And 47% struggle to manage the costs associated with network and IT. So they are revising it, sometimes hiring a cloud managed service provider that can help them reduce their spending, optimize the way that applications run, and also be better at doing what's needed in time, with the state-of-the-art hardware, all that's needed to be running and guaranteeing that everything goes as planned. And 47% say they struggle to ensure consistent app performance. So the way that things are running, sometimes they just lift and shift right to the cloud or even in the edge. So this needs to be better planned and executed, and a third party can help as well on this front. This is what I just told you, right? Based on our research, 72% of the respondents utilize a third-party partner for the network and edge strategy, especially when it comes to the 5G edge implementation. So you can see in all verticals, it's really a high number, and also for hybrid network architectures. So a telecom operator can certainly be a key partner for those enterprises when it comes to implementing not only the radio, but also the edge infrastructure necessary to provide what they need. It can be a bank branch, it can be a manufacturing facility, but they certainly need support, not only to implement the network, but also to manage it. Now we are going to talk about the market perspectives for the MEC market. This is basically a definition of the scope that we're following. So we are covering both hardware, software, and services, public and private implementations, all the market participants, not only the telecom piece, but also the revenue from cloud providers, from the infrastructure, edge applications, etc. It's a global study, which includes Latin America as well. And we are covering all the significant verticals, and I'm going to provide some of the key numbers here. So in terms of the total revenue of the market, in 2019, it was an emerging market. There was the first public MEC implementation by Verizon and AWS in the United States, for instance, in that year. The market most advanced was Asia Pacific. In China, the main telcos had edge infrastructures implemented, and they were running applications at the edge, especially considering China has a very interesting plan in terms of Industry 4.0 and transforming the manufacturing industry to a high standard by implementing new technologies. And they've seen a lot of use cases of 5G and multi-access edge computing being deployed. So most of the movement at that time was in China, and initial movements in the US. Other parts of the planet still didn't have a lot of implementations going on. So the revenue was relatively small for the telecom market, $64 million. The market has been growing considerably throughout the years. So in 2021, it reached $45 million. But we do expect most of the ramp up of the market to be occurring after 2024. This year, we've seen a lot of advancement in the space. So let's say in 2021, there were really few developments. And in 2023, there was really an expansion, a considerable expansion in terms of the private MEC deployments worldwide, I would say. So you see dozens of implementations by US telcos, by European telcos like Vodafone, in Korea, Japan, several countries with launches. AWS in public MEC is the most relevant one right now. So they have more than 30 metropolitan areas globally with public MEC network available. The idea is that more and more telcos join as partners and also help expand this. Other cloud providers like Google, like Microsoft, IBM are also investing a lot and partnering with the telcos to be deploying such services. And we do expect the market to go exponentially, especially due to this high adoption that we've been observing in different verticals that I'm going to show right now. Latin America, compared to the rest of the world, is a smaller piece of the market. Let's say most of the development until now has been in those developed countries. This year, we're seeing significant advancement as well in proof of concepts, in trials, in different enterprises, in manufacturing, mining, banks, etc. But still, there is a room in terms of monetizing it and generating a significant revenue stream. The telcos are doing a great job in terms of launching offerings, launching those projects. But still, in Latin America, it will take a little bit more time until the revenue is more significant. But still, it's 2% of the global market. The most developed region right now, it's Asia Pacific, as I spoke. After that, North America. Europe has been developing fast as well in this space. But still, let's say Latin America, the CAGR, the compound annual growth rate for the next years, is higher than other regions. It's almost 20 to 40% growth annually every year until the end of the forecast, but still is a smaller number compared to the other regions. This is expected. Usually Latin America is 2 to 5% of any given global market, but it will take some time until we see a major evolution on that. The ecosystem needs to develop, the partnerships need to be established, and also the projects need to start scaling to gain that relevance. We expect that more in the mid to long term in our region. In terms of the different verticals, the most important one is manufacturing and natural resources. As I said, most of the projects right now are concentrated in manufacturing, mining, oil and gas, smart ports, right? There's significant bets as well in terms of what can be done for telecom, media, and entertainment. And here, the telcos are really important in offering ultra high definition videos, virtual reality, all the metaverse applications fall in this category as well. So a lot of the things that are emerging require a network that runs with such low latency and can provide. An example is Meta and Verizon did a partnership in which the metaverse platform of Meta would be running over the 5G edge infrastructure deployed by Verizon, so that you don't feel motion sickness when using a VR device. You have a better experience on using virtual reality. So it's really an important development in terms of having the necessary infrastructure to run the new applications that are emerging. Automotive transportation and logistics, it's very important. As I said, smart parts was one of the first use cases, but then we have the connected and autonomous cars, all the communication, C-V2X, right? In terms of the cars with other cars, cars with the infrastructure of the cities, all the transportation system models interconnected. So this all can be improved with an infrastructure that can guarantee zero accidents, everything runs efficiently, and 5G MEC is the infrastructure that can be providing that. Other verticals like smart cities, healthcare, retail also have interesting use cases, but still it's a smaller fraction of the market. In terms of the split between private and public MEC, right now, private MEC is most of the market. As I said, there are, every cloud provider like AWS has more than 200 implementations of private networks with MEC. Other cloud providers as well have a significant number of those. Their big global telcos have been deploying a lot of private networks, assisting their customers on this journey. And public MEC is still more restricted. It's taking longer time than expected to ramp up. The infrastructure is deployed in several metropolitan areas worldwide. We still haven't got any public MEC infrastructure deployed in Latin America. We certainly will see that in the near future, but we don't have that commercially available right now in our Latin American region. Although we have a lot of, and I'll show you a lot of use cases in private MEC implementations. For the future, we expect private MEC to continue growing, will continue to be the most representative share of the market, but public MEC will start ramping up as well and having significant applications. The key applications in public MEC right now are more related to 5G gaming, which require really low latency to play in the network. All the VR, AR applications, the metaverse, and different other use cases that are emerging that I will show in the next slides. In terms of cases in Brazil, I just selected some of them, but we've seen a lot of traction. If you follow what the news, right? Let's say Embratel has done press releases of use cases with Nestlé, Porto de Suape, Gerdau, WEG, Einstein, Globo, Banco do Brasil, Bradesco, the very large companies in different verticals, both in manufacturing, banks, hospitals, media companies. We've seen more adoption and trials in different areas. And you can see that with Vivo, right? With some of the top enterprises in Brazil. Vale is the largest mining company, but Petrobras is the largest oil and gas company. Itaú is one of the largest private banks. Porto de Santos is the largest port in our region. Ting has an interesting use case with Stellantis, which is the manufacturing holding of Jeep in Brazil. So this is just a few of the cases that are in the market, which is public, right? There are many not disclosed yet, but this has happened basically during the past 12 to 18 months. And the curve is really going up, and the telcos are structuring itself and making it easier for the customer to acquire it. It's not requiring anymore a very significant investment upfront. In certain models, they can provide this as a service. So you pay a monthly fee to have access to search infrastructure and the managed services. So this has helped adoption in the different verticals. In terms of the growth opportunities, right? So this is basically a slide that shows the different applications. In the left, it was the cloud computing world. So you can see services such as storage, content delivery networks, web services, mail, internet search. Well, I wouldn't say it's basic services, but those are services that require, doesn't require a lot of data transmission frequency, and also the real-time requirement or the latency requirement is lower than what we've seen with more advanced applications right now. In the right, we can see the applications of multi-access edge computing. So at the top, connected cars, truly autonomous cars, 5G gaming, AR, VR, manufacturing, robotics, critical health and surgery, telesurgery, right? Remote surgery. Those are applications that really can't fail, Those are applications that are mission critical and require really real time, true real time. So we are talking here, in some cases, of 2 milliseconds of latency. It's virtually, the speed of light. It's really, you can guarantee that a surgeon doing a remote surgery with search infrastructure, there won't be any issues, on when doing it that could risk a patient life. Same with the cars. They are basically orchestrated and interconnected in a way that they won't be, they'll be communicating between each other with the infrastructure. There will be computer vision applications, seeing the images real time and taking actions with all the automations required. And this requires an infrastructure built to be operating at such level that applications, you really can rely on it wirelessly and be orchestrated by the telcos, right? You can imagine, like drones mentioned here, the quantity of drones that will be in place to deliver things from Amazon, for instance, in the US, and they can't collide, they can't drop and fall, they can't, they need to travel among each other with buildings, etc. This all needs to be orchestrated. The platform for this will certainly be a 5G MEC infrastructure. The intelligence cannot be built in the devices itself. It's very expensive and it's subject to error. So if you put all the equipment in an autonomous car, right now it costs $10,000 of radars, sonars, etc. for a car to move autonomously in the streets. This is not scalable, right? You need to transfer some of that intelligence and data processing to the network so this can scale and really guarantee the safety of everyone. And the infrastructure of the future for this is certainly involves edge computing. These are some of the examples by different verticals of MEC applications. So in manufacturing, predictive maintenance, collaborative robots, quality assurance, inspection, etc. Usually including computer vision, right? To do this quality inspection. In smart cities, smart video surveillance, smart homes and buildings, traffic, etc. in automotive, real-time connectivity management, high-resolution video surveillance. So all involves really real-time requirements, usually even video processing, very complicated things done using video, robotics, everything orchestrated and interconnected using such high level that is provided by 5G network slicing along with edge computing. Now we're going through some of the growth opportunities that we identify more specifically. As I told you, 5G gaming is one of the most important ones. It's important for the telecom operators to be engaging with players in that space to guarantee participation in this ecosystem. It's something that's really growing. During the pandemic, you know, the numbers grew a lot, and all the platforms are evolving in a way that customers are playing in the cloud, interconnected in the network, and those platforms require such low latency. When it comes to the gaming moving to platforms like 5G, like the smartphones that are capable of doing that, or even specific devices, this provides a lot of opportunity for market players, and the MEC infrastructure helps a lot improving the customer experience in that space. In transportation, in connected cars, also MEC plays a significant role in terms of not only zero accidents, but also coordinating this evolvement to C-V2X and all the car communication applications. All the standards are being discussed and approved by regulators right now as we speak. And this is the future of the mobility, for sure. You know, the cars will be connected and basically aligning transportation with each other and with the infrastructure. And the edge computing infrastructure being built is essential for this as well. So these are just some numbers regarding that. So in terms of connected cars globally, it's moving from 55 million produced in 2020 to 105 in 2030. So it's quickly evolving. The electric car penetration in the markets are growing as well. Those cars are coming with 4G or 5G connectivity already, and with a specific spectrum allocated for C-V2X to communicate with the network. And the latency is being reduced significantly, what's provided to cars, from 50 milliseconds before to 1 to 5 right now. So you can imagine the applications that can be running in a car and the way that things will be managed in the future using this infrastructure. Well, for virtual reality and immersive experiences, there's a lot of potential as well, not only for the metaverse, but also in smart stadiums, in theme parks, all things that require this and where AR and VR can be implemented to be enabling key applications in education, in healthcare, entertainment. So all that requires is not only a device. We've seen launches by Apple, by relevant players of interesting devices that provide highly immersive experiences. Those devices, when it comes to using them more frequently, and once they reduce in size to be more popular as well, they will transfer some of the processing capabilities to the edge as well. There won't be very supercomputers that you'll be using, very expensive, but likely it will reduce the price and some of the processing will occur on the smartphone or over the network. And MEC is one of the key enablers for that as well, both in private environments and in public MEC as well. So here's just some examples of AR, mixed reality and virtual reality, all enabled by edge computing. And those, in terms of video on demand, this is important as well, because right now, let's say in prime time, even in the US, 75% of the traffic is video. So it's really important to manage this properly. And customers will be using more and more video on their mobile devices. And there should be an edge infrastructure deployed to be providing that content with high throughput, with low latency as well to improve customer experience. And telcos can monetize that by offering their own platforms to clients with that performance that's needed for this new reality, right? You've seen resolution increasing from 4K to 8K in the mobile devices. So there will be significant traffic and needs to be properly managed by content delivery networks and also with edge computing infrastructures. Analytics as a service solutions, it's important as well in terms of deploying the capability to support that. Computer vision is one of the key applications emerging, being enabled by multi-access edge computing. You can imagine the capabilities that you need to process a video real time in multiple locations and being done everything automatically, Instead of having a traffic control center with a lot of video screens that the technicians go and check, with their eyes, you can have an infrastructure available throughout the city to process all this information and do analytics as a service over that. So some telcos are structuring big data and IoT units to be able to provide those services to enterprises, to cities, etc. And there are important applications evolving as well. It's one of the growth opportunities that we see. Here, in terms of what we expect for the future, in terms of the different applications, the ones requiring, less and less latency and more processing requirements, autonomous vehicles, as I said, robots, etc. And some technologies involved, like eye tracking, facial recognition, gesture recognition, all the biometrics things to validate a user, to guarantee security, etc., will require an infrastructure that provides really real-time processing of the data validated through the network. Well, in terms of the deployments, we've seen a lot of 4G implementations, and the 4G private networks are ready to evolve to 5G in the future. A lot of private networks deployed, 5G networks as well, with edge computing, network slicing, are important opportunities to enable the manufacturing sector to increase productivity, reduce accidents, right? Improves safety. And this is the next frontier, really, in terms of technology adoption. It's a way to reduce costs in the manufacturing plant, while also enabling mission critical applications to run in a good way. This is the examples that we observe, right? The evolution from 2020 to 2030. Basically, IoT has been a key enabler of digital manufacturing, along with digital twins, robots being implemented in the manufacturing floor. What we see in the future, it's what we call a lights out environment. It's basically a fully autonomous plant where robots are connected and engaged with each other. It's all coordinated by a virtual environment. So it's lights out because there doesn't need to be supervision. It even can be, there can be no lights in the environment. So all the manufacturing process is done autonomously with a 5G network at the center and the edge computing platform guaranteeing such a low latency that things don't fail, there's no intercorruption, and human interference is minimal in such scenario. For that to happen, basically the infrastructure that's being the core, it's 5G with multi-access edge computing, enabling AGVs initially, but also a lot of other applications in the near future. And in terms of smart cities, there's been implementations as well regarding different technologies, both Wi-Fi and also in recent cases with 5G. It can enable different applications in mobility, in security, public safety, many sensors that can be placed throughout the city to help automate emergency responses, waste collection, several urban challenges can be faced with such infrastructure. The cities are starting to evaluate the possibilities that this brings. And it's very interesting to help them achieve their goals, both in terms of carbon dioxide emissions, which they're trying to target with electric cars, electric buses, etc. But still smart solutions involving 4G and 5G are important at the core of those objectives. And also in terms of monetizing it, right? Helping cities increase their revenue with smart parking, with analyzing traffic images to put fines in terms of the behavior of the drivers, etc. So it can be something to help cities increase revenue, reduce costs, while also being compliant with the climate change, the emissions, etc. So this is it. I think I completed my time here. I'm sharing with you my contact details if you want to contact me by email or through LinkedIn. And I pass the word to Jose Otero now.
It was a very interesting presentation. I do have a few questions, but before I ask my question, I'm going to ask the audience to raise their hand if they want to ask Renato a question. The thing is, just raise your hand and then I'll give you the ability to unmute yourself. Any question from the audience?